Hello. For those of you that follow me on Twitter, you'll know that I've been working over the past 6 or 7 months at restoring this 1936 Philco 116X. It's almost tempting to call it a 1935 because the thing was built in like July 1935, but it is the 1936 model, much like they do with cars now. They did the same thing with radio in the heyday. Made them by the millions, and they were already working on next model's year during the current year. In fact, at my job, I'm working toward doing some 2018 model year automotive stuff. And as you know, it's April 2016, so yeah, looking a couple years in the future now. Anyhow, so I've come to a point with this particular restoration that I'm ready to plug it in and see if it works. Hopefully it works. It should work. Spent 6 or 7 months working on it, but I don't know. At this point, all I really did was clean it up. I checked all the coils. I checked all of the resistors, replaced as necessary. I replaced all the capacitors, both electrolytic and film, or paper, I should say, with new film types. And I tested all of the vacuum tubes on my tube tester. So, at this point, it should be a working radio, but then again, I don't know its original condition. All I did essentially was, recap it. So, I guess we'll see what happens, and we'll get it set up, and hopefully it works. So, before we can power up our radio, there's a few things we need. First of all, and probably most importantly, is an auto transformer. More colloquially, and that's hard to say, colloquially, there we go, we got it, referred to as a Variac. I believe Variac was actually a brand name. It's actually an auto transformer. And all it really is there's a knob on top that adjusts your voltage slowly in increments from 0 volts up to 140. Obviously, line voltage here in the US is about 120 average. So you're able to actually bring the voltage up on the radio slowly, say come up to maybe 10, 15 volts, stop, see what it's doing, make sure that everything is okay and there's no excess current being drawn, because that could indicate a short. This radio, this thing's from 1935. It's 80 years old, 81 years old actually. And I actually happen to know from the owner that the last time it was powered up was in the 1950s. So it's been 60 plus years since this thing's been powered up, and we just don't know what kind of condition it's in. Yeah, we've gone through, we've checked the resistors, we checked the caps. I went through and replaced any shoddy wiring, but the fact remains, we could plug this thing into the wall and sparks could fly and smoke could come out and it could just catch on fire. We don't know. When you have something this old, even when you've taken 6 or 7 months to restore it, the best bet is to just bring it up slowly and safely. Chances are everything's going to be okay, but this ensures that. So what you have a power switch. There's a voltmeter on the front, which is absolutely useless. I'll show you that here. You really can't see 120 volts on there very well, can you? You really just can't see what voltage you're at. I don't know why 140 volt AC Variac goes all the way up to 300, or maybe that one on the right there is probably even 400 volts. Why? It's just poor design. Anyhow, this one goes to 500 watts, or VA I should say, because it is AC, and it's got a fuse. So anyway, this plugs into the wall. I'm sorry. My videography skills aren't the best here. This plugs into the wall here, and then you just plug whatever you want to power in there, and then just bring it up. We're also going to want a isolation transformer, because the Variac does not provide any line isolation. Meaning, yeah, there's a transformer on the chassis itself that should protect you from line voltage and isolate you from the direct wall outlet. But again, the fact remains we don't know the condition of everything in this chassis. There's just too much wiring to know exactly how everything's going to operate. I'd feel a whole lot better having some sort of isolation upstream to provide the isolation that the Variac does not. So all this does is basically, you've got a cord that plugs into the wall, and then you plug your actual radio into here. In fact, I'll show you a diagram of how I'm going to wire everything up when I'm done showing you the equipment here, because it is a little bit complex just to try and describe and visualize. But this is just another layer of protection, and it should just be a 1-to-1 turns ratio transformer in there. So we plug 120 volts in, we should get 120 volts out, and the maximum for this particular unit is 1.25 amps, and it's got a little circuit breaker in there as well, which is another nice thing to have. I've added a fuse to my radio, 1.5 amp fuse, but it's just nice to have that extra layer of protection. I like protection. That sounded wrong, didn't it? Okay, one last thing. I made this one myself. You can probably tell it looks pretty gentsy. Yeah, it's not the best. But, it's not terrible. It gets the job done. I just kind of threw it together, put it in this Radio Shack enclosure. And what is it? Well, you can see it's got another cord in and an outlet out, and it just passes straight through. So what good is that, you say? Well, we'll turn it on here, and you can see it shows us what our voltage, our current, and our power is that we're running through it. So as we're running through the Variac, we can see what that voltage is as it's coming up very accurately. This thing's a lot more accurate than the meter on the auto transformer, that's for sure. Not quite as good as a fluke meter, but it's pretty decent. I'd say it's probably 1% accuracy, maybe a little bit better, and that's perfectly good enough for what we're doing here. And it does energy in watt hours, but I'm not leaving the thing on, so I don't really care. The important thing is really that voltage in the current, because if we blow the fuse or something, well, we want to know what our current was at that time. So this is also going to go into the circuit just so we can monitor what's happening. Okay, so hopefully I've got the lighting pretty decent here. It's actually incredibly difficult to get proper lighting here. I'm in my basement. It's just a room in my basement, so getting the lights set up correctly, all I have is spotlights hung up here, and I'm trying to get the angles right where I don't get shadows, but I get enough light. And well, there's only one outlet in the entire room, so getting the extension cords where I need them can be rather difficult. Anyway, oh, and by the way, you probably wonder why I'm always wearing a hoodie. I'm in Michigan, it's April, and it was 18 degrees this morning when I woke up, so yeah, you need the extra hoodie to stay warm. Anyway, I've drawn this schematic representation of how we're actually going to hook this radio up to test it. So it plugs into the wall outlet. You can see that it is grounded for our safety, by the way. Although that only goes to here because once we hit our isolation transformer, well, we lose our earth ground anyway. But that's okay. It's good to have this stuff grounded anyway, just in case we touch that by accident somehow. And then you see that goes directly to our Variac. You can see just from the schematic symbol here that there is no isolation, whereas here you have a core. Here it's not magnetically isolated, it's literally a wiper going across that coil, and it just taps off of a coil to get the voltage that you want. Alright, so my homemade meter that plugs into the Variac, so that's going to read the voltage out of the Variac as I bring it up, along with the current that's going out to the radio. That way we'll be able to see if there's any shorts or anything weird going on. Then the isolation transformer plugs into that, and you can see it's just a 1-to-1 turn ratio, and all it does is provide electrical isolation from the line, because you don't want to be touching mains, line voltages, because that's when you really get into trouble. If you were to touch this, this transformer core would saturate, and of course there's a 1.5 amp circuit breaker I didn't show in there, but it's also in there. That provides the isolation to prevent you from getting electrocuted. We talked about electrocution. So that's that piece. One other thing I'll point out is this isn't quite as necessary. We could do without the isolation transformer and everything would be fine. If we're working on one of the other types of radios, actually newer radios, believe it or not, the All-American 5 radio, which was popular in the 40s and into the 50s, actually did not have power transformers, because the goal was to manufacture tens of millions of these things and get the cost down and manufacturability down to a point where it was as cheap as possible, and they got every last component out that they could that they didn't need. Well, they didn't need a power transformer, so it actually had no line isolation, which wasn't unusual for the time, actually. A lot of things didn't. Things were quite dangerous back then. Anyway, all of that plugs into our radio, so let's go ahead and give it a shot, and we'll see what happens. Oh yeah, one last piece of the puzzle. Our radio isn't very much good without a speaker now, is it? So we've got the old cabinet here. I haven't done anything with it yet. My intent is to clean all of this up, get the dust out of there. You know, ugh, it's nasty. Clean up the speakers as well. And for now, though, we need to get our connector plugged into our radio. So I don't feel like pulling this whole soundboard and speaker out. I'm just going to drag this enclosure over to the bench, and we'll plug the speaker into the radio from there. Okay, I've got our crazy contraption all set up. You can see I have my meter here pointing at the camera. I've propped it up with an old capacitor. Hopefully you can see that in HD. This display is really bad. I actually bought it on eBay for $10 or something. It's not the best, but I wanted something cheap that got the job done, and it does its job. You know, I only need to use it occasionally for when I'm powering up these old radios whenever I have one of these projects. And I only do one every few years, so you know, I didn't want to spend a bunch of money on anything, and it's a lot of work to set up my meters. I could do that just as well, but it's just convenient to have something to plug into. Alright, first thing I'm going to do, I'm going to actually turn the radio on. Remember, there's no power applied yet. I'll give it maybe half volume there. I don't know how loud that'll end up being. Oh, one thing I was going to do, I need to add at least a little antenna here. Now this isn't much of anything. I don't know if this will pick up anything at all, but I just put a little piece of wire on there. You know, perhaps I should do a better antenna than that. Alright, well, it's still not much of anything, but what I did is I strung some alligator leads up to the ceiling there. Hopefully that is enough to get a good signal. I'm actually quite nervous doing this. I'm always really nervous when I plug in a radio for the first time and power it up. Again, because there's that situation where you don't really know what's going to happen. You know, this thing could emit some smoke for all I know. It could start sparking. I just don't know. And then, you know, I've done 6 or 7 months worth of work now. The last thing I want to see is this thing go up in flames, and you just want it to work, so there's that anxiety and that nervousness about it. But anyway, we'll soldier on and do it. I'm going to go ahead and turn my Variac on, and I think I might actually kill some of my lights in here, and hopefully you can still see, because I want you to be able to see the dial lamp, and that might make my meter a little bit easier to see too. I don't know. It might have actually just made it harder to see. So I'll zoom in on that, because that's what we care about, isn't it? Alright, Variac's on. I'm going to start bringing it up. There we are, 10 volts, 150 milliamps. That's not terrible. I'm going to bring it up to, say, 20. There's 20, about a quarter amp. Keep in mind, this thing draws almost 140 watts when it's operating normally. So we're only at 4.9 watts right now. And it always starts up higher than what it settles out at, because the heaters draw a lot of current as they're beginning to heat the tubes up. Alright. We've got just the faintest glow. We're at about 30 volts, and we've got just the faintest glow there from the dial lamp. And there's also a shadow meter lamp there. So that's a start. Anyway, okay, let's look at that meter again. Got 8 watts, 31 volts. Coming up fast here. We're at 50 volts, third of an amp. Don't hear anything yet. I can hear the heaters making clinking sounds as the heaters and the glass expands. So we're getting something. Let me look at our filaments here. We're about halfway up now. I see some heaters. I don't see all of them. Like I said, I did check all of the tubes, but it's possible some of them they might just not be heated up yet because they're bigger, and some of them might just be hard to see. Oh, I hear something. It's not a good sound. Well, that's not good at all. Let me try my dial. Tone doesn't do anything. Volume doesn't seem to affect it. Nope. Tone does affect it, which tells us something. Volume does not. Like I said, the dial doesn't. Let's see if we can changing bands. Doesn't seem to have any real effect. You know, I don't want to keep going up too far because it's only going to get worse. That was eerie, wasn't it? Okay, something's seriously wrong. Let me check it out. Okay, well, I thought about this a lot because, well, it's the next day. Yep, sorry. Ran out of time last night. Anyhow, I actually unplugged the speaker. I didn't want it to sit there and keep booming. I was just worried about you know, possibly doing damage to the speaker because it's probably hard to tell in the video, but it really was quite loud. And you know, 60 hertz, or at least it sounded like 60 hertz hum, continually going in a speaker like that, it will damage it. Plus, this thing's 81 years old. We got to be careful. So anyway, I got it up to full voltage now. We're running maybe a little high there. Let me back it down a little. There we are. 120 volts, 0.9 amps, 88 watts. It's fully heated up at this point. It draws less than the datasheet says. The datasheet for Philco for this particular radio says that it draws 135 watts while operating. I guess the speaker's not plugged in. Maybe that's with the speaker plugged in and operating at full volume. I'm not sure. Anyhow, so I've noticed some things. This isn't the cause of our issue, but this resistor here, this brown and orange resistor, it's getting very hot. I don't know if you can see. Let me see if I can zoom in. Do you see the bubbling? The paint is actually bubbling. Let me see if I can grab my temperature gun here and get a reading. Oh, we hit it there. 230 degrees Fahrenheit and climbing. 231, 234, yeah, and it just keeps going up. In fact, I let it get to steady state, and this is about as high as it gets. It gets a little bit hotter when I left it for about a half hour, but yeah, not a huge difference. Anyhow, I happen to know that this is relatively normal for this type of radio. I've worked on a Philco 660, which had a very similar issue. It had that same resistor in the same location, and it bubbled like that. The paint just eventually bubbled up and cracked, but the radio worked just fine. So I'm not quite sure what the issue was. Okay, so I thought it might be interesting to get a read of what the voltage going across this resistor is. We know the resistor value. It is, now these old resistors are different than our modern resistors, if you can't tell by its weird tubular design. In fact, because of the bigger ends on this, these are colloquially, it's hard to say, isn't it? Colloquially referred to as dog bone resistors. I don't know if they actually called them dog bone resistors back then, or if that's what we call them now. Perhaps it's both. I don't know. Anyway, that'd be interesting to know. So anyhow, the way you read these, since they don't have bands, they have a body color, an end color, and a dot in the middle. And that's the order that you read it in. B-E-D, bed, is how you memorize that. Body, end, dot. And it works the same as today's modern 3-band, or I should say 4-band with tolerance. These are 20% tolerance resistors. Color code. So, body is brown, which is 1. End is orange, which is 3. And dot means 3K. So this is a 13K ohm resistor. Let's power it back up. I turned it off because I didn't want it to just sit there and bake. We'll let it come up to steady state here. Warm up for just a moment. I didn't have it off for all that long, so it shouldn't take very long. And actually, it goes here. It's hard to tell. And here. We get 310. See, is that changing much as it warms up? A little bit. Well, let's just call it 312. Alright, so let's go ahead and calculate what that poor resistor is trying to dissipate that's making it bubble up like that. So, I'm going to do I squared R, but first we need to take our voltage, 312 volts, divided by 13 times 10 to the third, 13K, another parenthesis, squared, so there's our I, voltage divided by resistance, squared, times 13K ohms again, so that's I squared R, equals, what'd I mess up? Oh, I missed my 3, okay. And convert it to decimal. Wow. Essentially, 7.5 watts. That is a lot for that little resistor. I know it looks big, but resistors weren't very good back then. I'd say that's maybe a 2 or 3 watt resistor. I think what I'm going to do, just for good measure, is order probably a 10 watt resistor, and hopefully that will alleviate our issue. Maybe there's another underlying issue. I don't know that's entirely a normal voltage for it. So I'll dig deeper, but yeah, I think I might order a replacement 10 watt resistor for that anyhow. So like I said, that resistor isn't actually our issue because that's 60 hertz hum. You know, that resistor running hot isn't necessarily going to induce hum. And well, I can't verify that as 60 hertz. I could probably go to the effort to put my scope on it and see what kind of noise we're getting out of the speaker. Might be interesting, but I suspect it's just going to be a 60 hertz sine wave. So that tells us we've got a power supply issue of some sort. So we know where to start looking. Anyhow, this particular tube here could have caused me a red herring if I wasn't careful. That is a 76 tube. The tube that's supposed to be in that position, a 37 tube. So yeah, I didn't have the right tube. I did substitute one. That certainly could cause issues. However, I suspect that isn't the issue that we're having here. And in fact, I tested it. I'll save you the trouble. I pulled the tube out. Exact same issue.
Alright, so you can see I finally got myself a proper screen capture. No, it's not a live video screen capture like I should have. But, you know, most of those you have to pay for. They were free to try, but they were giving you a limited amount of time, you know, a matter of seconds. That wouldn't have been very useful. So, you know, if this blog takes off, you know, perhaps I'll end up purchasing that software. But for now, I was just looking for something quick and dirty that's free, and I can just throw a still picture in here. So this will work fine for now. Anyhow, I want to point you over to the left-hand column about halfway down. It says potentiometer. And then it says, to compensate for differences in characteristics of 6A3 tubes, adjust for minimum low-pitched hum when set is in operation, volume at minimum. Well, that sounds exactly like our problem. And I saw this before. I knew about the potentiometer, but I wasn't thinking. And I think this could be our issue. Because what this potentiometer is, it's actually across the 6.3 volt AC heater winding for our heaters on our tubes. So if that isn't balanced correctly, the noise, 60 hertz noise, is going to be directly coupled into our tubes right through the filaments or the heaters into the cathodes. So how that works is you have a potentiometer directly across that AC coil with the wiper of that potentiometer going to ground. And what that does is you should have, if it's set right in the middle, an equal resistance on either side of that winding, which splits the phases. You have an upper phase and a lower phase. When you get that potentiometer set exactly in the middle, then you've got phase balance, and it cancels out any what's called common mode noise. So your common mode rejection is going to be best when you had that set right in the middle. Well, I don't know where that potentiometer is set. I did clean it and turn it several times. It could be anywhere. It could be all the way to the end of its travel, stuck on one end, where you essentially have one phase at zero and one high. And, it's going to couple in some noise. So I think what I need to do is, hopefully what I need to do is just set that potentiometer to the middle, or at least adjust it until I get that hum to go away as it suggests, and maybe that will fix our issue. Here's hoping. Well, anyway, let's give it a shot.
Okay, so are we able to fix our issue? I've got it at 90 volts, a little higher than we did before. Let's try adjusting that potentiometer, which is right here on the side, and see if we can make that hum go away. It sounds like it's a little better. Let me try and bring it up a little more. We're definitely drawing more power than we did before. I forgot about the field coil, and there's a massive, let me see if I can show you there. This here, massive field coil on this thing. So anyhow, just wanted to point that out. That's probably what accounts for our big difference in power. It doesn't seem like there's much improvement here. Oh, I think we have a flaky volume control. Yeah, as I wiggle that, the hum kind of comes and goes. I'm not getting any stations. Given I'm only at 99 volts right now, I'm not full voltage yet, but I would think I'd get something. Sorry about that, my camera battery actually died on me. Anyhow, as I was charging the battery and waiting to continue doing video again, I realized I'm an idiot. I made a mistake. As far as that resistor heating up, well, the reason it was heating up is because the field coil of the speaker wasn't attached. And I remember that now from the Philco 660 I had worked on. That was overheating because I did not have the speaker connected. So, yeah, that's what happened. I measured the resistor. It didn't get damaged. It was still reading, within 20% tolerance of 13K. And actually, it was better than 10%. So I just left it. Anyway, I want to try this again. And I've now rebuilt the potentiometer for the volume control as well. So let me go ahead. Let's see what I'm doing here. bring the voltage up. Turn on our meter. I don't know, you probably won't be able to see that. Yeah, probably not. Anyhow, we're at 20 volts, 30, 40, 50, 60. Let's leave it there. That's where we started having troubles before. But I did adjust that pot, so hopefully that helped with that issue. Let it warm up. Drawing only about a ½ amp. Let's go up to 80. Drawing 0.85 amps now. Oh! 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 There it is! There it is! Oh, it sounds like hockey. It is Detroit after all. Hockey town. Let's bring it up. It's 100 volts. We're drawing 1 1/4 amps now. Yeah, so that field coil made a big difference.
Here's Nyquist twisting and turning into the left face-off circle.
Alright, we're at 120 volts. We're drawing 171 watts. Let me zoom in on that. That's actually more than the data sheet. I wonder if there's a problem. Look at that. 120 volts, 1.57 amps, 172 watts. Wow. This thing doubles as a space heater at that power. It still sounds pretty bad. I think perhaps there's something else wrong. It might be that tube there that we talked about. That's a 76 tube, it's not a 37. I do have a 37 on order, so we'll have to see if that makes a difference. Although probably these caps need to be adjusted as well in here for the intermediate frequency, the oscillator, the antenna, that sort of thing. Let me turn off the lights here. You can see that glow a little bit better.
Through into the corner, penalty is over, the Flyers have dodged the bullet, and they are now at full strength.
There we go. How's that?
Straight out shooting the Flyers 8-5 here in the first period. Denning works for the puck in behind the goal.
Turn this off.
In there. Yurko trying to jam it away. He does. Dudas after the puck swings it.
Let me try another band. Nothing there. Oh, that's the long wave. There might not be anything there. Not much selectivity. Might have other problems. Oh, got something there. Tone seems to work. There's a lot of options there. 1, 2, 3, 4, 5, 6, 7. Wow. It's actually a lot of bass. I don't know if you can hear that. It still sounds pretty bad. Something's wrong there, you know. We're not picking up much. For the shortwave. Yeah, I haven't done any adjustments yet, so it's not surprising we're not really getting much of anything. That pot might still be a little bit finicky there. Something's a little bit weird with that, you know?
150 alumni at that game tonight, Edmonton against the Canucks. Into the Protected netting. They stopped the ball at that time. Back in behind that Red Wing and goal. The Red Wing Flyers could not manufacture a scoring chance. Like a dangerous situation right there for Detroit. Timeout, 4:42 to play in the opening period. Red Wings 1, Philadelphia nothing. This is the Detroit Red Wings Radio Network.
When it comes to great deals on new Chevys, we really...
A lot of bass in this setting.
Whalen Chevrolet. And since you're listening to the hockey game, come to Buck Whalen Chevrolet and we'll face off against the competition to give you the best deals on new Chevys. We'll hit you who even tries to beat our prices.
Is that automatic volume control? I don't know if you could hear that swell in volume.
Provide the best in customer service. Our goal is to assist you any way we can. The deals...
Anyway, well, yeah, that volume pot's still trying to see if it's self-clean a little, maybe. It's real flaky down at the bottom end.
I thought in the doghouse was just an expression, a figure of speech.
Well, the doghouse is a very real place.
How long are you condemned to your canine quarters?
Too soon to tell, but on the bright side,
Doghouse is a
I think
bright
it's
side.
the
loud.
wife can't throw a lamp this far.
Yeah, she's been working out.
Order Jimmy John's sandwich delivery today. Jimmy John's. Freaky fresh.
Maybe I'll be able to squirt some cleaner in the potentiometer. Anyway, wanted to show you that. Looks like we got it working, so excellent. Anyway, there you go. That was the first power-up and some troubleshooting of my 1936 Philco 116X. So if you enjoyed that video, make sure you give it a thumbs up on YouTube. Subscribe to my channel if you haven't already done so. And follow me on Twitter at OhmsAtHome. We'll see you.